It may shock you, but on an industrial scale, electricity is rarely generated in reserve. If fuel or water power is used to generate energy, then the process can be regulated and not generate excess electricity. But there is a problem with renewable energy sources. You can tell the sun to shine later and the wind to blow in the evening. How to save renewable energy and give it to consumers during peak hours? Scientists are working on various options. We have already discussed one of them, sand batteries. The alternative is gravity batteries. How long can they work and how much electricity can they give out? And most importantly, can they change the world of renewable energy? Find out in today's video. The first device in which the force of gravity made it possible to obtain energy for the mechanical movement was the ordinary pendulum clock, invented by Huygens in 1656. But it took 250 years for the principle of using gravity to reach energy. In 1907, the first pump storage system was built in Switzerland, which according to the general principle is referred to as gravity. Initially, pumped storage hydroelectricity was used, obtained by burning fossil fuels. It was cheap because it was produced during off-peak hours and some of it would still be used in vain. This energy was used to pump water from the lower reservoir to the upper one. At peak times, gravity would rush the water back to the lower reservoir, pumping turbines and generating electricity in the process. Today, such systems also use energy from renewable sources. For more than a century, the method of pumped storage hydropower has been widely used. Statistics claim that today it is the most popular method of storing electricity in the world. For instance, of the total number of energy storage facilities in the United States, 95% use this particular technology. But gravity can be used in many ways, and water is not required. Moreover, different forms of gravity batteries can potentially solve the main problem of renewable energy: how to save all the energy that both the sun and wind give, and then transfer it to consumers at the right time. And at the same time, how to make the system cheap and wear-resistant. In the past few years, various startups have emerged that offer a new concept for a gravity battery. About one of them, the Gravitricity, we will go into further detail. But first, let's understand how the new concept of a gravity battery actually works. The essence is simple. In the charging mode, the system uses the electricity received from the outside to lift a heavy load from the bottom to the top. This is how potential energy accumulates in the load. When you need to extract energy and get electricity, the load falls under the force of gravity and the electric motors switch to generator mode and give energy to the consumer. You have to understand that the load does not fall instantly. It is designed in such a way that it goes down slowly. That is, the system is capable of delivering energy for several hours. In fact, it all depends on the weight of the load and the height of the lift. At the same time, switching from charging to discharging mode takes only a few seconds. That is, the system is able to respond to peak loads quickly. It is this principle of operation that Gravitricity, which in 2021 built its first test prototype, also known as a demonstration sample, proposes to use. The system was installed in the Port of Edinburgh. Its design is similar to an elevator, only inside it is not a cabin for passengers, but for two 25-ton loads. They slowly rise to a height of 15 meters due to the energy of the sun and electric motors, and then within a few seconds quickly fall down under the influence of gravity. The startup notes that the blocks are lowered faster than they should, and this was done specifically for demonstration purposes. But this is enough to impress. Although not only that, the device can fully power a nearby village with electricity for a few seconds. The power of this design is 250 kilowatt. But such systems can potentially deliver from 1 to 20 megawatt of peak power and do it for 8 hours. Gravitricity engineers estimate that a 20 megawatt power grid could power 63,000 homes for every hour of discharge. To do this, the company plans to use a load of a larger mass, but it is not reported which one, and lift it to a much greater height. Although it would be more correct to say drawing down instead of lifting, as for these purposes, Gravitricity suggests using abandoned coal mines, which can be several kilometers deep. Agreed, there is something symbolic in the fact that the remnants of the coal industry can get a second life and give impetus to the development of renewable energy. Because the key problem was collecting solar and wind energy is that if there is nowhere to store it, then it is simply wasted. What is the advantage of such gravity batteries over lithium-ion ones? The first and obvious one is cost. In terms of the cost of storing a megawatt-hour alone, they are at least 2 times cheaper than their lithium-ion counterparts, $171 versus $367. For comparison, this figure for sodium-sulfur batteries is $532. And another innovative development, batteries with flowing electrolytes flow batteries, $274. The second and no less important advantage is service life. Lithium-ion batteries degrade quickly, depending on the number of charge-discharge cycles, in 5 to 10 years. The service life of the gravity battery can be up to 50 years without much maintenance and repair costs. Third, the extraction of lithium and other metals is associated with difficult working conditions and violation of human rights. What is more, the stocks of elements are depleted, which does not make the technology promising in the long run. Don't forget about the fire risk of lithium-ion structures. And the last, much less space is needed to accommodate gravity batteries, especially if you do it the way Gravitricity suggests. Such a decision will be especially relevant for Europe, where there are many old coal mines and not much free space for installing huge areas of lithium-ion batteries. What is the future of this technology? So far, it is still very young and, so to say, raw. The first ideas and developments appeared only in 2017, and even Gravitricity built the first test sample only in 2021. Now, the company is looking for suitable mines in the Czech Republic, Poland, and on other continents. Estimated launch of the first battery is in 2023 or 2024, with an estimated capacity of 4 megawatts, which still require a mine with a depth of about 1 kilometer. But you need to understand that Gravitricity is a small company consisting of 14 people, with a capital of several million pounds. Therefore, much depends on the search for funding, the assistance of the authorities, and the faith of investors in the project. But Gravitricity believes that by successfully building the first battery, it will be much easier to scale. The technology also has its downsides. For example, skeptics criticize concrete as a cargo, reminding us that the technology of its production is very dirty. Gravity battery developers have already responded, saying they are ready to use pressed construction debris, recycled concrete, and many other suitable materials. Another nuance is that not everywhere has ready mines, which means that new ones will have to be drilled to build some batteries, or build high-rise structures, and this increases the cost of the project. Although even these minor shortcomings do not cover the fact that the technology of gravity batteries is really promising as well as perspective, therefore not only Gravitricity starts working with it. For example, the Energy Vault Swiss project built a test prototype in the form of 6 cranes on a 110-meter tower, each of which moves a 35-ton load. Installation power, 80 megawatts of peak power. Another project is being implemented in the USA by Aris. Although its principle is slightly different, the sun's energy is used to pull concrete trains uphill, which then come back down. One 300-ton train is capable of generating 50 megawatts of power. The company is currently building its first site in Nevada. From a technical standpoint, gravity batteries seem to be a great energy storage solution, especially if it is the energy of the sun or wind. The synergy of the forces of nature allows us to get more without affecting the ecosystems around us. Gravity batteries are cheaper and not as harmful and capricious as lithium-ion batteries. They also do not require specific terrain like pumped storage hydropower. In fact, they can be installed anywhere and they will work for decades. But they need to implement at least one full-fledged project in order to understand if any pitfalls can bury a promising technology. Will we see them everywhere? We'll find out soon.